Welcome to section 8.1, part 1. This is the 61st session of the CISSP exam prep series. In this session, we'll start building secure systems from the ground up. We'll answer several questions. Why should security be part of design from day one? Who or what is a subject and what is an object? What makes transitive trust dangerous? How do open and closed systems differ? And why should you never trust default settings? Why does this matter beyond the exam? Because you rarely inherit a clean slate. Picture a team shipping a new patient scheduling app, wiring it into a cloud vendor, and reusing an old payment library. Every one of those choices bakes in security, or fails to. When you understand secure design, you catch weak assumptions during architecture reviews before they harden into expensive rework. So why should security be part of design from day one? Because retrofitting protection is slow, costly, and leaky. Bolting locks onto a finished building never fits as well as designing them in. Modern Secure by Design guidance pushes 3 ideas. First, own your customer's security outcomes, so products ship safe out of the box. Second, be radically transparent about flaws, sharing what you learn so the whole community improves. Third, drive security from the top, with leaders accountable for it during development. Security becomes a business goal, not a late patch. Who or what is a subject and what is an object? Every access request has 2 sides. The subject is the active side that asks for access. That is often a user, but it can also be a process, a service, or even a whole organization. The object is the passive side being requested, like a file, a printer, or a database. Here is the twist. These roles are not fixed. A service that is the object of one request can turn around and become the subject of the next. Think of a relay runner who receives the baton, then hands it on. The same entity plays both parts. What makes transitive trust dangerous? Transitive trust is the chain where if A trusts B and B trusts C, then A quietly ends up trusting C. It behaves like simple math. If A equals B and B equals C, then A equals C. The problem is that A never vetted C directly. Say a company blocks a distracting website to keep staff focused. A worker who cannot reach it directly connects to an outside proxy or VPN, and that service reaches the blocked site on their behalf. The block is bypassed through the middleman. Anytime you allow a bridge, you may inherit everything on the far side of it. How do open and closed systems differ? A closed system is built to work mostly with gear from one maker, using private specifications that are not published. An open system follows shared industry standards, so it plugs into products from many vendors through common interfaces or APIs. An API is just an agreed set of rules for how software components request things and exchange data. Open systems are far easier to connect, which is exactly why they draw more attackers. Their standard parts create predictable entry points, and there is a huge shared body of knowledge on how to break them. A closed system is harder to attack, simply because an intruder must first learn its unfamiliar internals. Openness buys interoperability, but it demands stronger defensive coding and layered defense to stay safe. Is open source the same as an open system? No, and mixing them up will cost you exam points. Open versus closed system is about integration and standards. Open versus closed source is about whether the internal code is visible to the public. Open source code invites public inspection to improve it over time. Closed source code leans on the vendor to fix and revise it. Any combination is possible. A closed source program can run as an open system, and open source code can run as a closed system. Read every question slowly, because these terms sit one word apart. Why should you never trust default settings? Because defaults are chosen to make installation painless, not to make you secure. Vendors pick settings that minimize support calls, which is why so many devices ship with a known default password. That convenience is a gift to attackers, who scan for exactly those factory settings. Treat every default as the worst possible option for your environment, then review each one deliberately. A lockdown configuration is less friendly and does less out of the box, but that friction is the point. If you build products, document every setting so customers can harden intelligently instead of guessing. So let's bring it together. Security belongs in design from the very first stage, driven from the top and shipped safe by default. Access always involves a subject and an object, and those roles can swap between requests. Transitive trust lets risks sneak in through a trusted middleman. Open systems trade easy integration for a larger attack surface. And open source is a separate idea about visible code. And defaults are built for convenience, so you must review and restrict them yourself. Get these foundations right, and every control you add later lands on solid ground. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.